Okay, welcome to part 2 of our chapter 14 discussion over drain waste and vent system design. The second part of this discussion, the part we're talking about now, is going to start on slide number 22, and we're just going to kind of step through each of these tables and how they work, and then we're going to go through example 14.1 in the book slowly and methodically just to make sure everybody understands how all of that kind of came together. So first of all, we're taking a look at drainage fixture units per fixture type. And you can tell that some of these things have a minimum trap size listed both in inches and millimeters, as well as the total DFUs expected for that fixture type. Now the specific DFU for any fixture that you're going to purchase or spec for a design is going to be listed in the product information. So these are guidelines, just keep in mind, but it also gives us a resource that we can use to sort of try out how all of this works. So just keep that in mind. Take these numbers with a grain of salt. They're not universal. But the first step obviously is to decide on the fixture type, and then we're just going to carry that straight across and see what the minimum trap size is and what the total DFU rating is, and that would be per fixture. So if you had 10 of them, you would multiply 10 times whatever number's over here. When we get down a little bit farther, you can see that the trap size is not listed for some of these things. So like for this urinal here, all the way down to this water closet here. And the reason for that is we're not actually connecting a trap to those devices. The trap is integral, so it's built into the fixture itself. However, they are each rated for DFUs. So the drainage fixture units are going to be listed for each of those things, which will help us decide on the size of the drain that's going to have to be connected to it. Keep in mind also that most of these fixtures are going to have sort of a predefined drain size that you would be able to look up and determine prior to purchasing or speccing this particular fixture. The next table is going to help us determine the minimum size of the pipe for both the fixture branch and for the stack. So depending on the conditions of the number of fixture units, but also the number of branches that are connected to the stack. So these first two columns here, actually the second and the third column here, are listing maximum drainage fixture units for a particular pipe size. Okay, so again, right here it's for the branch. This is the horizontal branch that is being used to connect all of the fixtures to the stack, and then this is the actual waste stack itself. So in other words, if we have, say for example, 20 drainage fixture units, DFUs, connected to any single horizontal branch, we're going to be in this row right here. And so we come across and we can see that that would be a 3-inch drainage fixture, 3-inch pipe for that horizontal fixture branch. And then using that same number for drainage fixture units, let's say we have 3 of the same rated at 20 drainage fixture units each connected to a single stack. That would be 60, right, connected to that stack. And so we come over here, and this would be one stack of 3 branch intervals or less. So this column is going to be used if we only have up to 3 of these connected to that stack. So if we, again, back to the example I gave, if we had 3 rated at 20 drainage fixture units each, that would be a total of 60. So we come over here and we find which one of these is going to be capable of handling 60 drainage fixture units. Unfortunately, there's a big jump between the 3-inch pipe and the 4-inch pipe, so we'd have to go down to the 4-inch in this case, because 48 isn't going to cut it if we have 60. So we'd have to come all the way down here for 240. We come across, and that would be a 4-inch stack that we would be able to use. So for scenarios where we have more than 3 branch intervals connecting to a stack, we have to come over to these last 2 columns. And these last 2 columns, we have to find a case for the stack and then a case for the branch interval sizes based on drainage fixture units. So the numbers just change a little bit, but it works essentially the same way. So if we use that 70 number or that 20 number again and say we have 4 branch intervals, each at 20, so we would be able to use the 3-inch pipe still for the branch intervals, but now we've got 80 drainage fixture units, so we'd have to come over here and look down, and we'd have to go down and again, connect with a 4-inch pipe. So the numbers on the example I gave are exactly the same, but only by chance. There's no real correlation between those two examples. So just to recap this table, it just kind of depends on how many branches, how many branch intervals we're going to be connecting to the stack. If it's 3 or less, we're going to be using these 2 columns. If it's 4 or more, then it's going to be these 2 columns. This table, 14.3, is helping us size the building drain. This one's a little more complicated, but it's not too bad. Remember that when we get to the building drain, we should be including all drainage fixture units combined. So every single fixture in the entire house that's feeding into this drain is going to be summed up. We're going to have to add those all together. And the drainage fixture units, these are the maximums listed here. You'll notice that each of these 4 columns is showing a different slope. So this would be the least steep at 1/16 of an inch equals a foot, over to the steepest, the 1/2 inch equals a foot. And there is a maximum slope that we can use for these drains. So we have a minimum and a maximum, 1/16 to 1/2. And then of course we also have 1/8 and 1/4 inch per foot included in that. You'll also notice that the steeper the pipe is sloping for the building drain, the more drainage fixture units we can push through it. And that sort of it makes sense, right? Because we have more help from gravity to push that water down through that pipe. Therefore, it doesn't have to be as big. So if we take an 8-inch building drain and we come across and look at this, you can see that at a 1/4 inch, or excuse me, at a 1/16 of an inch per foot, we can connect 1,400, up to 1,400 drainage fixture units to that. At 1/8 of an inch, 1,600, at a 1/4, 1,920, and at 1/2, 2,300 drainage fixture units. If we're going to design this thing, we probably are going to know the slope that we're going to need to use before we start figuring out the pipe size. So if we say, okay, we have enough room to slope this thing in a 1/4 inch per foot, that's pretty standard slope. We're just going to stick with this column right here. Simply a matter then of determining how many drainage fixture units are connected to that building drain, coming down and finding a number that's equal to or greater than that number. So if we had, for example, 400 drainage fixture units that we're trying to push through the drain pipe, the building drain, we just come down and we find that this 480 is going to satisfy that requirement we come across, and we've got a 5-inch building drain. So the last table, 14.4a, this is going to help us size the vent. So the vent stack is what we're dealing with here. This one's laid out a little bit different in terms of how that it works. So let's just kind of step through the process real quick. For this one, we have to think about 3 different criteria. Number 1, we need to have already worked out the size of the soil or waste stack. So that was 2 tables ago that we talked about that, right? That was the one where we could figure out the diameter size of the waste stack. So we need to know that before we do this. We also need to know the total connected DFUs on the stack. That would be the waste stack. So we know how much volume could potentially be passing through that so that we can size the vent. The third piece of criteria we need to know is the maximum developed length of the vent. That would be the vertical height of that vent that's going to be passing up and oftentimes parallel to the waste stack, as we saw in those diagrams earlier in the chapter. All right, so let's come up with an example here. Let's say that we have a 5-inch stack that we determined in a previous step, and we're going to be running 250 DFUs through that stack. So we come down here and we look at in this column here, and we see that there are 3 options of 5-inch pipes. So we come across here, this one is 200, that's not enough. We said 250. So we're going to drop down to this row right here. Now this table gets a little bit hard to track as you're going across because there are not horizontal lines running through it. So I'm going to do my best to track across. And let's say that the total height of the building is going to be around 30 feet. So let's say 35 feet is going to do it for our vertical vent stack, and that's the maximum developed length. So with that in mind, we can find this 5. We come across, we can see that we're well within our 250 on this column, or in this row right here. So we bring that across, and if our vent stack is 35, this column is not going to work because we're only at 30. So we come across to this one. This one, 70, is going to be more than enough. And we run straight up from there, and we can see that our required vent diameter is 3 inches. So let's take a look at example 14.1, and you can do this in your book just as easily, but I've laid it out in a slightly different format, so hopefully it's easy enough to understand. So first of all, we're going to start off. Let's determine the minimum pipe diameter for horizontal fixture branch, waste stack, vent stack for the following scenario. 2 apartment buildings or 2 apartment units share a common stack. They also share a common horizontal fixture branch. Each apartment has a bathtub, a water closet, a lavatory, and a kitchen sink. So we got 4 fixtures in each apartment. The vent stack goes up through the roof and is 22 feet long. So let's see if we can size these things using the methods we just learned. First of all, we need to figure out how many DFUs are on each apartment and total. So we have bathtubs, water closets, lavatories, and sinks. There are 2 of each. So let's see how many DFUs each of those has. So bathtubs, we come across here, we can see that that is going to be 1 DFU. Next, we want to look up water closets. So we come down here. Whoops. I don't think we can see water closets on this slide for some reason. I must have clipped that a little bit. Sorry, no, I didn't. It's right here. Okay, so water closet, we're going to call that private. This is not a commercial building, so it would fall under the private category. And as we bring that across, I'm going to try to keep it horizontal. I believe that is saying 0.5, but I'm not sure. That doesn't seem right. I think we're going to just go with water closet general use, and that one is 4. Okay. And then lavatories. Let's see what we got for that. Lavatory, and there are 2 options there. So, or no, there's just 1. Lavatory with 1¼ inch waste, it's calling. So since there's only 1 option there, we'll use it. We come across here, and there's 1 DFU for that. And finally, kitchen sinks. And if we come down here where it says sink, sink flushing, sink service, sink poultry, sink per faucet. So none of those, but we come back up here and it is listed under kitchen sink here. So we kind of have to know a little bit more about the kitchen sink perhaps, but if we just use this standard one without a dishwasher or waste disposal connected, we bring that across, and that's 2 DFUs each. So we go to the next slide and we just do the multiplication. So there's 2 of these things each, and these are the DFUs we just determined. We multiply that out and we add it all together. We have a total of 18 drainage fixture units so far. All of those drainage fixture units are going to be connected to the same branch interval, and so that's the number we're going to use to size that first pipe. So because we are 3 or less, we're going to be using these first 2 columns. First, the horizontal fixture branch. We know that we have 18 DFUs going into that. We come down on this list and we can see that there's a 20 listed there. We come across, and that is going to be a 3-inch pipe for that. Okay, so we come over to the stack. We're going to size that thing. Also, 20 is going to work there. And for the stack, we're only going to need a 2.5. It's interesting that the horizontal branch and the stack's actually smaller than the branch, so we could feed into a smaller vertical pipe for this in this case. That said, the book does point out that a more appropriate way to do that would be to feed into the same size stack. So even though we could technically use that 2.5, since we're running a 3-inch fixture branch into it, we would probably make that stack 3 inches as well. The next, we're going to size the building drain. We know that if it's just a duplex, we're just doing these 2 apartments, the total building drain volume in DFUs is going to still be 18. And we're going to be able to get by with a pretty small horizontal drain for that one. We've only got 18, and we're running the minimum here at 1/4 inch is 21. So somewhat interestingly, in example 14.1 in the book, it does not talk about the building drain. It doesn't talk about how to size that thing. So if we're running 18 DFUs into it, we know we could get by with a 2-inch building drain, but we also know that we're running a 3-inch stack into it, so probably not going to downsize that thing. And I think if it was mentioned in the book, they'd probably say that it would be more appropriate to just keep that building drain the same size as well. So technically, maybe either one of these would be correct, but more than likely the plumbers are going to do it with the larger drain. Which brings us to the vent stack. And remember, the vent stack required 3 pieces of information: the size of the soil stack, total connected DFUs to the soil stack, and the length of the vent, the length the vent would have to be. So you may remember we talked about a vent size of 22 feet. And so we're going to be well within that for most of this stuff. But we also know that there's a 3-inch soil stack that we determined. So it's going to be one of these 3 rows. And we know that there are 18 DFUs connected. So it's going to be the second one right here. We bring that across and we see that 60 is going to be well covering our 18 DFUs. So we have a required vent diameter of 2 inches. Okay, so that is example 14.1 in your book. If you want to look through the book and just kind of double check everything I described there, make sure that it makes sense, that would be a good idea. Just a note of caution as you're going through this stuff. In example 14.1 on page 512, there is a couple of typos. In the last paragraph of the example, the book states a 1.5-inch diameter pipe is selected for the vent stack, but a 2-inch pipe should be used since there's no option for 1.5-inch pipe. So that's just a typo. And then another one on example 14.2, which I'd also encourage you to go through and look at. The first paragraph of the waste stack does contradict itself by first listing a 4-inch pipe, and that one is correct, and then it lists a 3-inch pipe, and that is incorrect. So if you want to dig that out of the book, feel free. But if you're going through and looking at the book and you got confused by that, I want to make that painfully clear that that is a typo in both those cases. So even though the assignment, the questions associated with this chapter are laid out differently than what we looked at here, you should be able to piece together how to use those tables and how to answer those questions. There also is going to be a helper video that's going to be linked in case you get stuck on those questions, that questions assignment that you can watch, and it walks you through the first couple of examples. So if you have questions, reach out. Otherwise, hopefully this gets you where you need to go, and we'll see you all next time in class.